So let's answer this example. Select a W18 shape of A992 steel that can resist a service dead load of 100 kilopounds and service live load of 300 kilopounds. Effective length KL is 26 feet, no? Remember, this W18 is not in the column design load, no? Okay, balik na dito sa table na. The table, I think I already discussed, no? Wala siya, since W14, W12, W10, W8, mo lang siya ang na-added to for W shape. Kining W18, wala siya. What I mean is, in the table for dash 1, okay, dito ta sa table for dash 1, no? Okay, this is 319. Yes, if you try to look at this one, okay, W14, no? So good siya sa W14, kani siya nga table, the available strength in axial compression. So, na siya ASD, LRFD, kining allowable strength and the design strength. Now, for W14, there is W14, no? There is, yes, still W14 continuation, another continuation, W14, W12, no? Na siya, W12, W12 continuation, W10, W10, after ano is HP na siya, HP shape. Side shape, wala siya sa wala siya sa column load label, no? Strength ng table. So, magbase tayo dito sa table 1 for this one. For the shape. The shape is W-1, yes. W1-1. So, balik to sa yes, these W shapes for W shapes. Excuse me. Balik sa shape of A99 steel. So, first is we have to compute the factor load PU, no? It is 1.2 dead load plus 1.6 live load. Using the given dead load and live load, the factor load is 600 kilopounds. Then we assume a value for the critical buckling stress, this FCR. Say the FY, di ba? For A992 steel, the FY is 50 KSI. 50 KSI siya. So, in here, the first iteration, no, first solution is 33 KSI, an arbitrary choice, 2/3 of 50. Munang 33 KSI. Then, we compute for the required gross area, no, using the relation kaganina is the factor load is 600 divided by, for the LRFD, the fifth resistance factor is 0.9 buckling stress, assume no critical buckling stress 33. The value for the required area is 20.2 inch square. And then select in the table, no? The problem says that select a W18 shape, so we have to stick on the W18 shape, no? Then the required area is 20.2, meaning you have to select a shape slightly greater than this 20.7, 20.2 inch square, then compute, no? So, slightly greater than W18, so we have to select, no, in the table, W18 shape. This is, ano man to? This is W30, so paubos na, no? Because W18 man. 16 naman siya. This one. So, W18, no? For area 20.2, diba? Kung tanaw mo area 20.2, this is the area. The second column, W18, 22.2, 20.2. The area which is slightly larger than 20.2 is this W18 by 71, no? 18, this is the depth, 71, this is the pounds per foot, no? So, say, we have to select this. So, say, try W18 by 71, which has a area. Then compute for the slenderness ratio. I-check na to ang slenderness ratio. No? Effective length KL is given as units of variation. We have to see it in the table. So, if this W8 by 71, what siya radius of variation given this one per foot. The radius of variation, since minimum, it is on the axis YY. No, kung tan-anin mo dire, under sa 71 is, the radius of gyration is 1.7. This one, radius of gyration minimum is 1.7. Then times 12, because the KL, this is in feet. Because this radius of gyration, this is in inches. So you have to convert to inches. So times 12. The answer is 183.5, less than 200. So okay. No? Then compute for the Euler's stress, no? Which is Fe. No? The Euler is pi squared E over KL over R squared, no? For the steel, the modulus of elasticity in English unit is 29,000, no? Then KL over R is, we computed as 183.5 squared. The value for Fe is 8.5. Then, check, no? Compute for this one. The 4.71 square root of E over Fy. If you remember in our previous video, no? Beginning videos for this topic, compression members, we have to evaluate this KL over R compared to this 4.71 square root of E over Fy, no? And since this KL over R is greater than 113, no? Greater than aning 4.71 square root of E over Fy, use the NSCP equation, char, sa pangalan aning equation, this one, FCR 0.877 Fe. Actually, nani siya sa kaning flexural buckling stress. This is our previous discussion sa previous video. No? Yes, this one. In elastic columns, if KL over R is greater than greater than 4.71 square root of E over Fy, or Fe is less than 0.44 Fy, use equation NECP, equation 505.3-3, or AISC, equation E3-3, which is FCR equal to 0.877 Fe. So, mo ni siya diri. We use this equation FCR equal to 0.877 Fe because KL over R is greater than 4.71 square root of E over Fy. No, this is in ECP, equation 505.3-3. Then, substitute the value for Fe, which is 8.5. So, the value of FCR is 7.45455 KSI. Then, substitute this one to this design strength, diba? This nominal strength is also can be written as this resistance factor times the buckling stress, which is we computed as 7.45455 KSI times the gross area. This gross area, this is the area of the section that we select, no? that we select, say this one, W18 by 71, the gross area ni table is 20.9. So, mo nang atong gigamit diri 20.9. And since, kung tanaw nimo siya, the design strength resulted into 140 kilopounds, but the factored loads is more than the design strength, meaning this is the limit, this is the design strength, I mean the limit. Dapat dili siya molapas sa factored loads or applied loads, which is 140 ra siya. Then sa factored loads nimo compute di ba is 600, less than 600, so not good, no? Again, we try another value for FCR and another section. We select another section because initial estimate of FCR was so far off, no? Assume a value about halfway between 33 and 7.455 KSI, but we assume first 33, 2/3 of 50. So sa result is far off layo ra, no? So we try this between ani. So try 20 KSI. So mano pa ni siya atong gamito, no? We have to again compute, no? Balik-balik ra gyapon ang procedure. Compute for the required gross area. So using the value of the factored load, computed factored load 600 divided by resistance factor 0.9 times this assumed value for the critical buckling stress 20 KSI, no? Equal to 33.3 inch square. So we have to select again a section slightly greater than this 33.3 inch square, no? So kung atong tanawon sa table, the problem specifies W18. So dito gito mo stick sa W18. Pila to? 33.3, no? This is the area now, the second column. 33.3. 33.3. The next, I mean the section, no? Larger than 33.3 with area larger than 33.3 is W18 by 119, no? This one. So we try this section W18 by 119 with area 35.1, slightly larger than 30.3 inch square, no? Then again, we have to check for the slenderness ratio. The minimum radius of gyration, ibase na po nato sa kaninga section nga atong gi-select. Bag-o. So, the minimum radius of gyration, we have to see it in the table, di ba? Wala man dire. So, I think naa siya sa continuation sa abos. Pila to? 119, no? The radius of gyration is at axis, minimum radius of gyration is at axis YY, no? Then 119, the radius of gyration minimum is, sakto ba? 2.69, no? Yes, 2.69, this one, radius of gyration. Compute, still less than 200, so okay. Then compute again for the, using this value of the slenderness ratio, compute for the Euler's stress or FE. FE is 21.7. Then compare this one, since we already computed the value of this one is dili man siya ma-change, the value of 4.71 square root of E over Fy, because we are kanang always be using this E and Fy for the steel A99250 KSI, no? So the value for this is still 113. Comparing this value to this KL over R, the slenderness ratio new, no? Pila to 113, still greater than ang KL over R. So still you have to use this equation E3-3 or NECP equation 505.3-3, or this equation FCR is equal to 0.877 FE. Now FE is computed as 21.27 no KSI. So FCR is 18.65 KSI. Then substitute this value for the critical buckling stress no computed in here no to get the design strength or LRFD. Then check kung less than or greater than the factored load which is the 600 kilopounds. So kung the answer for this one is 589 kilopounds pero doon na siya pero ang kuan is less than gyapon siya sa 600 pero at least doon na siya no. Still not good bisan pag duol siya but still less than the factored load because this factored load is this is the bali existing or the applied loads, di ba? Dili siya dapat mulit lapas sa design strength. This one, the resistance factor times the nominal strength. So, not good. This is very close. So, try the next larger size. So, what is the next larger size of this W18 by 119? Try the mantong ganina. So, we try this W18 by 130, no? So, we try the W18 by 130 with gross area according to table is 38.2 inch square. Again, compute for the slenderness ratio, no? Using the minimum radius of gyration na sa katong bag-o na nga section, no? So, in the table is 2.7. Still less than 200. So, okay. So, compute again for the value of the buckler stress or FE using this value of the slenderness ratio, no? The denominator. So, the value for the buckling stress is 21.42. Then, compare again, no? Using this value of FE. Okay. Compare again the slenderness ratio KL over R to this one, no? 4.71 square root of E over Fy. Kung greater gihapon siya, so greater gihapon na because 115.6 man. Use the AAS equation E3-3 again or in ECP 505.3-3 or this equation FCR is equal to 0.877 FE. Now using the FE computed FE with new FR, new section, no? So 21.42 substitute the value for FCR, use this value to compute for the design strength, which is finally greater than 600 factored load kilopounds. No? So, okay, this is okay, good. This shape is not slender because there is no footnote in the dimensions and properties table to indicate that it is. So, local buckling does not have to be investigated. Local buckling is not an issue. So, kung inyong tanawon dire, the W18 by 311 wala siya footnote, no? Unlike sa this other sizes like W21 by 57C, there is a small c. Meaning this value here, this shape with C is slender for compression, no? So, naa siya mga footnote with C, F, G, and H, no? But kung C, naa siya small c, kani siya, meaning slender siya, you have to evaluate the local stability, no? The stability or local stability is an issue for this section with footnote. Then the final answer, no, for W18 is this weight by 130 pounds per foot. This is for LRFD.